Welcome to The Explainer, everyone. Today, we're diving right into one of the absolute most intense, high-stakes technological battles of our entire generation, the AI chip war of 2026. Now, if you've been following the massive boom in artificial intelligence, you already know that the physical hardware running these giant models is literally just as critical as the software itself. Today, we're taking some fantastic research from the field to frame this whole narrative as a clash of titans. Think of it like this. On one side, we have an entrenched Goliath, who essentially built the arena from the ground up, and on the other side, a rising rebellion made up of the world's largest tech companies, and they are building their own custom silicon. We're going to break down exactly how this battlefield is shifting, the strategic drivers behind it, and what it all means for the future of AI. But, to really understand this rebellion, we first have to understand the Goliath. And to do that, just consider this number, 75 to 81%. According to industry analysts, that represents NVIDIA's estimated AI accelerator market share looking ahead to 2026. This is a company that recently reported a mind-blowing $75.2 billion in data center revenue. And get this, that was in a single quarter, not a year, a single quarter. They are, without a doubt, the undisputed heavyweight champion of the world right now. But as we're about to see, holding on to that crown is getting a lot more complicated as the market expands. Okay, let's dive into this. How on earth did NVIDIA build such an incredible lead in the first place? Well, equity research from Safra actually breaks this down into a 4-layer moat. First up, there's the GPU architecture itself, which is just uniquely suited for the heavy, parallel processing that AI demands. Second is networking. They don't just sell the chips, right? They sell the scale-up and scale-out networking that literally allows tens of thousands of GPUs to talk to each other and act like one giant brain. Third, they've got this privileged VIP access to the most tightly constrained supply chains on the planet. And fourth, and honestly, this is probably the most important piece of the puzzle, they have the CUDA software ecosystem. Yeah, that fourth layer is the real kicker. It's all about the CUDA flywheel. Released way back in 2006, CUDA is basically the software layer that lets developers actually program these GPUs. And today, there are over 7.5 million developers building on this exact platform. It creates this almost unbreakable lock-in effect, because migrating away from NVIDIA isn't just about going out and buying a different chip. It means you have to rebuild all your performance optimizations entirely from scratch and retrain your entire engineering team. The switching costs are just massive. So this brings up a huge, glaring question. If NVIDIA has the absolute best chips, the best networking, and an incredibly sticky software ecosystem, why on earth are the hyperscalers, giants like Google, Amazon, Microsoft, and Meta, spending billions of dollars to build their own chips? Why walk away from a formula that is clearly winning? To answer that, we really need to unpack the core strategic drivers that are fueling this entire custom silicon rebellion. The research points to a sheer necessity for both survival and scale. First off, cost reduction. Running vast, endless AI workloads on third-party hardware racks up massive operational expenses. Building that hardware in-house, that drops the cost significantly over time. Second is hardware-software control. These hyperscalers want to optimize the entire stack specifically for their own unique services. Third is supply chain resilience, which we're definitely going to touch on in a second. And fourth, workload specialization. See, these companies don't always need a chip that can do everything. They just need a chip that does one highly specific thing flawlessly. And those four strategic drivers are the exact reason the big tech giants are yanking chip design in-house. And that brings us perfectly to the weapon of choice for this rebellion, the ASIC. Now, ASIC stands for Application-Specific Integrated Circuit. So unlike a general-purpose processor that tries to be a jack-of-all-trades, an ASIC is a custom piece of silicon designed from the ground up to do one very narrow task, like, say, sequential token generation for a large language model. Because it doesn't have to be good at everything else, it can be hyper-efficient at the one specific thing it was actually built for. And this brilliantly illustrates the contrast here. Think of the general-purpose GPU, like the one on the left, as a Swiss Army knife. It's muscular, it's flexible, and it can adapt to almost any workload you throw at it. But the custom ASIC on the right? That's a scalpel. It is stripped down, highly optimized, and meticulously designed for a very narrow set of rules. And this is exactly where the hyperscalers are finding their edge. By designing ASICs tailored specifically for their own massive internal models, they can achieve a performance per watt that off-the-shelf, general-purpose chips just genuinely struggle to match for those specific tasks. And you can literally see the strategic shift playing out in the data. Looking ahead to 2026, shipment growth rates from TrendForce project custom ASICs growing at a massive 44.6% compared to 16.1% from merchant GPUs. Now, to be fair, the GPU market overall is still much, much larger. But the ASIC rebellion? It's growing nearly 3 times as fast. The tide is undeniably shifting as these massive tech companies pull their silicon design in-house. So who exactly is leading this counteroffensive? Well, it's basically a who's who of tech royalty. Google has its TPUs, which they've actually used to power their internal AI for years now. AWS has Inferentia and Trainium. Microsoft is rolling out Maya and Athena. Meta has MTIA. And incredibly, even the AI pure players are getting in on the action. OpenAI is reportedly partnering with Broadcom to build a custom inference chip codenamed Jalapeno. And the whole goal there is specifically to slash the staggering computational costs of running their large language models. So this isn't just a passing trend, right? It's a massive insourcing dynamic where NVIDIA's biggest customers are slowly but surely transforming into their competitors. But there's another major strategic driver pushing this shift to custom silicon. And honestly, it has absolutely nothing to do with code or power efficiency. It's all about mitigating global risk. Relying on a single vendor for what is arguably the most critical infrastructure of the 21st century, that exposes these massive companies to huge global supply chain shocks. The tech giants desperately want to diversify their hardware sources, so they aren't completely paralyzed if just one link in the chain breaks. Now, what's really interesting about this is how it highlights incredibly tight choke points in the physical manufacturing process itself. I mean, TSMC commands roughly 90% of the leading-edge logic foundry market. 90%! And SK Hynix controls 62% of the high-bandwidth memory market. The physical creation of these chips is highly, highly concentrated in Taiwan and South Korea. So while designing custom ASICs doesn't entirely remove a company's reliance on foundries like TSMC, having control over the actual design gives hyperscalers a way more leverage and flexibility in a supply chain that is frankly fraught with geographic concentration risks. So the crucial point to take away here is understanding the balance of this new battlefield. The hyperscalers are absolutely winning on specific fronts with ASICs, getting that maximum cost efficiency for narrow, repetitive tasks. But, and this is a big but, NVIDIA's GPU defense strategy is just brilliant in its flexibility. Because the AI landscape is constantly rapidly evolving with totally new model architectures, a GPU can just absorb those new workloads with a simple software update. An ASIC, meanwhile, well, that might require a multi-year, multi-billion-dollar redesign if the underlying AI math radically changes. Actually, there's a quote from the equity research that just hits the nail on the head here. It says, "The wider the range of AI applications grows, the stronger the economic case for a general-purpose accelerator becomes." It's basically a massive game of tug-of-war. As tasks become rigid and operate at a massive scale, custom silicon wins on cost, for sure. But as the frontier of AI keeps expanding into totally unknown territories, the flexible, general-purpose GPU remains absolutely indispensable. Which leaves us with this final, provocative thought to ponder. As we look beyond 2026, and as AI models continue to branch out and specialize, will the ultimate future of hardware belong to the adaptable generalist or the hyper-efficient specialist? The answer to that question will likely dictate the next $1 trillion in the tech economy. Thank you so much for joining me on this explainer. I really hope this deep dive into the strategic drivers of the silicon supply chain give you a clearer picture of the incredible AI chip war unfolding right now. See you next time.